All right, welcome back. It is time for notes. Yay, notes! We are going to be talking about the universe today. I cannot wait. We are only going to do the first 12 slides of the notes today. So here you go. Slide 1 done. How amazing was that?
Great.
I know. So we are going to go ahead and continue. And there we go. So the universe. That's everything. Universe means everything. It's all the planets, all the stars, all the matter. It is everything that's out there. So it's not just our solar system. It's not just the Earth. It's everything. So if the universe is everything, how many universes can there be? What I want you to do, talk to your table, try to figure this out. See if you can determine how many universes we have. On your mark, get set, 10 seconds, go. So, if the universe is everything out there, one thing that has everything in there. Did y'all hear me say that? One thing that has everything in it, that's the universe. It is the one thing that has it all in it. Now, there are different solar systems, different galaxies. Only one universe, one thing that has all of it in there. And then everything else is inside that universe. Now, you do have different ways to break down that universe, but there is just one universe because it's the thing that has everything in it. All right. So our current theory that we're going on is how this universe started is the Big Bang Theory. It's not the show, which is an amazing show, by the way. I mean, it's funny stuff.
It is.
Gotta love some Sheldon. But this, what we're talking about, is how our universe, how our solar system, how our stars, how our planets, how they all came to be and where they are. So it says that there was this tremendous explosion. Boom. It sounded about like that. Just boom. And they actually have evidence. They have things that lead them to believe this. It's not just some scientist saying, you know what? I bet there was a big explosion. Tremendous. Boom. So it's not just that. They actually have reasons. They have evidence. They have proof to support this theory. But it is just a theory. All right, so I said that there's some evidence. Well, this evidence starts 13 to 15 billion years ago. Man, that's a lot of days. 13 to 15 billion years ago. Part of this, the light elements in the universe, as in not the heavy, not like bright, shiny, but as in not heavy. Redshift and microwave background radiation. So there's always this radiation. There's a redshift. And redshift, once we learn a little bit more about the electromagnetic spectrum later this week, that'll make a bit more sense. So that's one of those that throughout the week we're going to continue coming back to it. And the light elements. Those are the things on the beginning of the periodic table. So scientists analyze the spectral lines. So what they do, they get this thing, this instrument, and they look at light. It can be light from a star. It can be light from our star, the sun. It can be light from another galaxy. So what they're doing is they're looking at all this light, and when this light is separated, it actually can show the individual elements. What they use, the tool is called a spectroscope, and it separates the light into identifiable quantities. So they'll have different lines. They're looking through it. It's going to have this like rectangular looking thing like that. And then they'll have like a red line here and here. And then maybe we'll go over here, get some yellows, a whole bunch of yellow. And then we'll continue it, maybe some over here in the darker colors, something like that. And this little spectrum that they see actually identifies a specific element. And so they can tell what elements are in different stars, what things are actually being burned, based on looking through a spectroscope and seeing these colored lines. These percentages were actually, when the Big Bang Theory started, they were predicted, and then later scientists, they actually found evidence that supported that. So in the beginning, they were mathematically predicted that, oh, if this Big Bang Theory were actually true, that would mean you'd have to have this percentage of hydrogen, this percentage of helium, et cetera, et cetera. And then, oh my goodness gracious, technology advanced. They could actually find out and see percentages of elements, and they nailed it. So, uh-oh, now this Big Bang Theory is gaining more momentum. All right. Now, redshift. When something is moving away from you, its color shifts. Like I said, we will get a little bit more into that later. When something's moving towards you, its color shifts. If it's moving towards you, it's going to be called a blue shift. If it's moving away from you, it's going to be called a red shift. And that's because of the spectrum of colors, the rainbow. Does anyone remember learning the colors of the rainbow in order? What's your little memory device that you use to remember all the colors of the rainbow? Roy G. Biv, so we'll go with that. It is one of the more common ways that people remember it. So Roy G. Biv, right? So if we have this, R is on the far left side, isn't it? And that's red. The blues, violets, all that, that's on the far right side. So red's on the far left, the blues, the darker colors on the far right. As far as energy is concerned, and the amount of energy that light has, this right here has less. It has a longer wavelength, and it has less energy. This right here has more energy. Has a shorter wavelength, and it has more energy. And the wavelength, the length of the actual light wave, is what determines the color. So when you have a shorter wavelength, that means it's more on that blue range. Longer wavelength, more on the red range. And this is for visible light. So now think about this. If something is moving away from you, would that make a wave seem longer or shorter if it's moving away?
Longer.
Longer. So if it's moving away from you, a longer wavelength is more like a red. So it shifts and appears more red because it's moving away. Now if something's coming straight at you, would that make the wave seem shorter or longer?
Shorter.
So it's going to be more like the blue, which has a shorter wavelength. So the scientists, they found this shift. They found that there is a red shift of other stars and other galaxies. So things are moving away. Now, if things are moving away, that means at one point in time, weren't they closer?
Yeah.
So right now, I'm standing next to you. If I start moving away, we can think back. And at some point, would it be logical to think, if I'm moving this way, I was closer to her before? Okay. That's one of the pieces of evidence, that they can see everything is moving out, and they can trace all these different galaxies, the different things in space back to a central location. So everything's going back to a central location, the center of the universe. And since it's all coming from a central area, they're saying, oh, there must have been a massive explosion to send everything out in all directions. Next up. So if there's a massive explosion, would you consider that to be pretty hot? Yeah? I would think so. I mean, something to blow up and make all these different stars and everything else, it's probably going to be pretty hot. So, the early universe was made of very hot particles. That makes sense, doesn't it? Massive explosion enough to make everything go boom. Pretty hot stuff. The universe cooled rapidly as it expanded. It's out there in outer space. Not too hot out there. There's actually evidence that this happened. The rapid heat, rapid cooled, left a background radiation of microwaves. And scientists can actually receive those microwaves. It's called the cosmic microwave background radiation, or CMB for short. How can they estimate the age? Well, they know how fast things are moving out from that central location. And they can measure that speed that things are moving out. That's the rate of expansion. So based on that, they can calculate backwards and figure out, well, if everything's moving at about this speed and we're this far away, we can kind of trace it back, use a little bit of math. Oh, it's about 13 to 15 billion years ago. All right, so that's enough about the Big Bang for now. We'll talk more about it throughout the week, but that's the basics. Big explosion, and there's evidence to prove it. Some of that evidence is the background radiation. It is the elements that are present in the stars, and we can see that if we use our instruments and look at the different things. And the redshift. All right, now the universe has lots of things in it. Some of those things include galaxies. Anyone know what galaxy we currently reside in? Spend about 5 seconds, see if anyone knows it. Talk to your table, go. All right, I heard a lot of correct answers. Yes, we are in the Milky Way. And there are other galaxies out there. Inside those galaxies, we have stars. We also have nebula. We have quasars. We have comets. These are not the only things out there, but these are the things that we're going to be discussing.
What's a quasar?
I bet we're about to find out what a quasar is. But before we do, we're going to find out 3 different types of galaxies. So galaxies can be categorized 3 different ways: spiral, elliptical, and irregular. And this is all based on the shape. So based on the shape, they can be spiral, elliptical, or irregular. All right. So a spiral galaxy has a bulge or a gravitational point in the center of the galaxy. Then spiral arms going all the way around. So it looks like a spiral. You can see the spokes coming out and going around. This is the Andromeda galaxy shown right here. And we think our galaxy, the Milky Way galaxy, looks very similar to this. Our next galaxy is an elliptical galaxy. It just looks like an ellipse. A very bright center just a big blob of stars, mostly old stars. Doesn't have the spiral arms jutting out. And the last type of galaxy that we're going to be talking about is an irregular galaxy. It has no specific shape. It doesn't fit into the other two that we've learned about it, so they just call it irregular. A lot of random dust. Has some stars in there, but no specific pattern. All right, I told you earlier that we were only going to cover 12 slides today. Tomorrow, we will start the star life cycle and learn a little bit more about the stars that make up these galaxies.